Hi everyone. So in this video we are going to start studying about signed number representation. So this is a very important topic and also very conceptual topic as well. And I will tell you 99% of the students are not comfortable in this particular topic. So you have to listen to my words very carefully. Everything that I am saying, you need to take full amount of attention while watching this particular lecture. Okay, so I require your complete attention now. So till now we were talking about only unsigned number, right? Like I told that write down what you will write down 23 in binary. So you wrote it down. 23 in binary, that would be 23 in binary. That would be 10111. So you wrote it down in that manner. There was no negative sign. Nowhere we used any negative sign. But we need to represent negative and positive both numbers now. So we will use certain ways. So first we will see signed magnitude representation. Then we will see r minus 1's complement representation. Then we will see r's complement representation. What is r? R is the base here. What do you mean by r? R is the base. So if base is 10, if base is binary, if base is 2, then r minus 1's complement will be 1's complement. R complements will be 2's complement. Decimal 9's complement. In here it would be 10's complement, right? In octal it would be 7's complement and 8's complement, and in hexadecimal it would be what we say f's complement, f's complement, or ef g's complement, you can say efg. Yeah, because 15 will be f and this would be g's complement, you can say. Now we are going to study about our first representation, that is signed magnitude representation. But before that, just answer this particular problem. Express 24 in binary representation. We have already studied it, right? Decimal to binary. How you will express 24? 8, 4, 2, 1, 16. 24 you need to represent. So it would be 1, 1, 0, 0, 0. So that would be the answer. That's it, right? Very easy. We have studied this binary representation. So there was no sign involved, nothing like that. Now we are going to study signed magnitude representation. Look, these two names can be confusing. This is signed number representation. In signed number representation, all three will come. Signed, r's complement, r minus 1's complement. And this is signed magnitude representation, which is a separate thing. Signed magnitude representation is separate from this one. Signed number representation, that is the union set, and these ones are subsets. So signed magnitude representation is a part of signed number representation. So now we are going to study about signed magnitude representation. So here the MSB bit will tell the sign and rest of the bits will tell the magnitude. Okay, if MSB bit is 1, that means it will show negative sign, and if MSB bit is 0, that means it will show positive sign. So MSB bit will show the sign and rest of the bits will be modulus. Okay, represent plus 24 in signed magnitude representation. You need to represent plus 24. So MSB bit will be sign bit. So plus means 0. What about 24? 24 can be represented as 1 1 0 0 0, right? 1 1 0 0 0. So this is how I will denote 24 in signed magnitude representation. This is signed magnitude representation. 24 in signed magnitude representation. So this bit is the sign bit and these are the magnitude. Okay, so here how many bits you required? 3 plus 2, 5 and 6. Total 6 bits required. Total 6 bits required. So to represent 24, here total 6 bits were required. In binary representation, to represent 24, how many bits were required? 5 bits required. Total 5 bits required. Here which bit is added more? That is sign bit. So here total 5 bits required. Represent minus 24 in signed magnitude representation. So same thing will happen, just initial sign, this is the sign of negative and rest all will be the same. Okay, now this is the question, which decimal number is that? So this number is represented. So which decimal number is that? So first one will denote sign and it will be 1248. 1248. So minus 13. Wrong answer. Why it is wrong? Because where did I say that this is signed magnitude representation? I did not say that it is signed magnitude representation. I have to tell that it is a signed magnitude representation. Then I will say that my MSB will be my sign bit. But here the number is 11011. I did not say this is a signed magnitude representation. Where is mentioned that it is signed magnitude representation? This is simply binary number. This is a simple binary number. So 1248, 1248, 16. So 16 plus 8 is 24 plus 3, 27. So this is the correct answer. Okay. This is wrong. 3, 8 plus 3, 11, 27. So this is the correct answer. 27 is the correct answer. Minus 13 is wrong. Okay. If I had written this answer, that is wrong. So you have to tell whether it is SMR or not. This question is given. The given number is represented in signed magnitude representation. Which number is that? So what will be the answer for this? So 1, 1, 0, 1, 1. So this bit will be sign bit. That means minus sign. And this bit will be the magnitude. So 1, 2, 4, 8. So 4 plus 1, 2, 4, 8. So this will be minus 11. So 1, 2, 4, 8. 8, 4, 12. Okay, here. Okay, yeah, sorry. 1, 2, 4, 8. Better to write always. 8 plus 2, 10. 8 plus 2, 10 and 11. Okay, it would be 11 only. This would also be minus 11 only here. 1, 2, 4, 8. Yeah, minus 11. So now this will be the correct answer. Okay. This will be the correct answer because it is represented in SMR. So that you need to take care. Now let's see next question. You need to represent 24 in sign magnitude representation but in 8 bits. So MSB bit will be of sign. So that will be 0. Now rest 7 bit will be denoted to 24. Rest 7 bit 3, 3, 6 and 7. Now how will you denote 24 in 7 bits? 1, 2, 4, 8, 16. So 1, 1, 0, 0, 0. 1, 1, 0, 0, 0 and rest to these two will be 0 only. Basically, I need to denote 24 in 7 bits. 24 in 7 bits. How will you denote it? 24 in 7 bits. This bit is sign bit, so that will be 0. Now 24 in 7 bits. So it will take 5 bits. So 1, 1, 0, 0, 0 and rest 2 bits will be the magnitude. So 5 plus 2, 7 plus 1, 8. So answer would be 000, 000, 11, 000. 000, 11, 000. So 11, 000 and then 2 more bits. This will be 24 only and because of for the plus there will be a 0 sign. So this is the correct answer. What about this one? Here it will become 1 only. This sign will be 1 and rest all bits will be the same. Just the sign is changed. For negative sign 1 will come. Now 24 I need to represent in 7 bits. So 24 I am representing in 7 bits. There you go. Okay. So this is the answer. So till now again I am telling you because all things are being will be getting mixed now. Okay. So you will be getting confused, that I know. So that's why we are going step by step. So binary number representation was there and sign magnitude representation there. So we have studied two kinds of that. So binary number representation we already know. In sign magnitude representation, first MSB will be of sign +1 for negative, 0 for 0 for positive, and they have to mention if it is a sign magnitude representation or not. Okay, that's it. And in 8 bits, this is how we will mention, and in 8 bits negative number, this is how we will mention. Now, the range of binary number. So 0, 0, 0, 1, this will be 2, this will be 3, this will be 4, this will be 5, this will be 6, this will be 7. So in 3 bits we are going till 7. So in n bits we are going from 0 to 2 to the power n minus 1. Do you remember it? For 4 bits total possible combinations are 16, but In decimal, we will go till 15 number. So from 0 to 2 to the power n minus 1. From 0 to 2 to the power n minus 1 for n bits. This we already know. Now in sign magnitude representation, this represents the sign. So this is plus 0. This is plus 1. This is plus 2. Because this is the sign bit. This is the sign bit. So this is sign bit. This is plus 3. This is minus sign. Minus sign, 0 0 will be 0 only. This is minus sign. 0 1 will be 1 only. If I ask you represent minus 1 in a signed magnitude representation, so how will you represent it? 0. And how can you represent 1? 0 1. Right? Are you getting this point? 1 can be, or you could have done in this manner as well, that I can represent 1 in this manner. So this would also be the answer. 1 1 can also be the answer. This is also correct. You need to represent minus 1 in a signed magnitude representation. So 1 will come for this, and this 1 will be 1 in binary can be written as 1 only. So 1 1 can also be the answer. If I am saying represent minus 1 in signed magnitude representation but in 3 bits, so 1 bit will be of sign, and what about the other 2 bit? Other 2 bit will be used for 1. So how will you write 1 in 2 bits? 0 1. So 1 0 1. So this is what you will get. And what this will denote? What this will denote? Minus 2. And what this will denote? Minus 3. So what all numbers you are having? Minus 3 2 plus 3. Here minus 0 is not equals to plus 0. But actually minus 0 is equals to plus 0. But in signed magnitude representation, minus 0 is not equals to plus 0. So if there are n bits, then how you are going? So let's understand it. So if there are n bits, total number of possible combinations are 2 to the power n. Minus 2, because zeros are 2 different zeros are there, divided by 2. Basically, why I am doing in this manner, I just want to tell from where the formula is coming. I need to find this number, or sorry, from this number. I need to find this number. How will I find this number? If I am having 3 bits, so total possible combinations are 8. So I should be getting from 0 to 8, but 2 zeros are there. So I should be getting from 0 to 3, but negative numbers are different. So divided by. So basically from, I have 6 numbers now. I have 6 numbers. 2 zeros are different, that is being repeated. That is being eradicated now. Zeros are gone. Now I am left with 6 numbers. So 1, 2, 3, 4, 5, 6 I should have made, but 3 negative and 3 positive will be there. That means minus 3 to 3. So 8 minus 2 is 6 by 2. Are you getting this thing? If you are not getting, then you can simply remember it. So from minus 2 to plus of this, or it can be written as minus 2 to the power n minus 1 minus 1 2 plus 2 to the power n minus 1 minus 1. Very important. This is the range. अरे यार, now let's try writing it for 4 bits. If there were 4 bits, so total combination would have been 16. Total combination would have been 16. 2 zeros will be there, 14. 14 numbers, 1 2 3 4 5 6 7 8 9 10 11 12 13 14. But we have to represent positive as well and negative as well. So divided by 2. So 14 by 2 is 7. 14 by 2 is 7. So from minus 7 to plus 7. Okay, and if you put the value in the formula, so if you put 3 here, so sorry, if you put 4 here, so 2 to the power 3, 2 to the power 3 is 8. So 8 minus 1 is 7. So minus 7 to plus 7. Same thing you are getting. Okay. Represent minus f to 7a in sign magnitude representation. But this is in hexadecimal. So this negative sign is there. That is the sign bit. Now can I convert this number into binary? Yes. What will be f? 1 1 1 1. So this negative sign is showing you, that here 1 should come. Rest all will be the magnitude. 2 in 4 bits, 0 0 1 0. 7 in 4 bits, 0 1 1 1. A is 10, 10 in 4 bits, 1 0 1 0. That's it. This is the signed magnitude representation. What about this one? The minus sign is saying you 1, 7 in 3 bits, 0 in 3 bits, 2 in 3 bits. That's it. This is signed magnitude representation. What about this one? Minus 43 but base 5. From base 5 to you are going to base 2. Can you directly do it? No. So first I need to go to base 10. So forget about the minus sign. Minus sign is there. That I am keeping in mind. That minus sign is there. Minus sign is there. What about 43? So 43 can be written as 3 plus 4 into 5 to the power 1. That means 23. So this is 2310. So this number can be written as minus 2310. So minus sign bit 1. What about 23? 23. You could have done in this manner as well. 23, 11, 1 will be left. 5, 1 will be left. 1 will be left. 0. So that would be the answer. That 1, 0, 1, 1, 1. Right? Or you could have think in this manner as well. 8, 4, 2, 1, 16. So 23 you need. So this would be 24. So 16 plus 4 plus 2 plus 1 would be 23. So 1, 0, 1, 1, 1. In that manner also you could have think, or you could have gone in this manner as well. So this would be the signed magnitude representation. Signed magnitude representation. Well and good. So this we have studied about signed magnitude representation. Now we are going to move to r minus 1's complement representation. R minus 1's complement. So for 10 it would become 9's complement representation. For 8 it would become 7's complement representation. For 16 it would become f's complement representation. For 2 it will become 1's complement representation. So how do we find a complements representation? So 9's complement representation of 27, what that would be? So what is the, how many digits are there? Two digits are there. So what is the maximum number of 2 digits in decimal? 99. So 99 minus 27 you need to do. This is how you can find your 9's complement. So what you will get? 72. This is the answer. Okay. If you need to find 7's complement representation of 7's complement representation of 35. So what is the basically write 7 7 2 times. 7 7 2 times minus 35. Maximum number would be 7 7. In base 8, what will be the maximum number of 2 digits? That would be 7 7. So 2 minus 4. Basically, if I had to write the 7's complement of 432, what I would do? 7's complement representation of this number. So I would do 777 minus 432. If I need to write 9379215, 9's complement of this. So what I will do? 9 9 9 9 9 9 9. So 9379215. So I will just subtract it. So just how many digits are there? These many 9s I will write. That's it. Okay. So this is 42. What about this one? So f's complement, that means f A23. So 15 minus 3, that would be 12. And what is 12? C. 15 minus 2, that would be 13. What is 13? D. And 15 minus 10, that would be 5. So 5DC, that would be the answer. Okay. But these are not important at all. No one will ask you, and nowhere you will use it. What is important? Because our computer will understand binary only, 1 or 0. So the important is 1's complement representation. This is the important part. So you need to check first, what is the procedure? You need to check if the number is positive or negative. If the number is positive, then the signed magnitude representation will be 1's complement, it will be 2's complement as well. So if number is positive, you don't need to think much. But if the number is negative, then first you will write sign magnitude representation, then you will keep the sign bit as it is and subtract rest of the number from 1 1 1 1 1. or you can take complement of each magnitude bit. Let's understand by the example. So this is the first example. First, what we need to check, we need to take ones complement of this, ones complement representation of plus 21. How we will take ones complement of this? We need to check whether the number is positive or negative. If the number is positive, it will be same as SMR. It will be same as SMR. So for positive sign, 0 would come. And how will you denote 21? That would be 16 plus 4 plus 1. That's it. This is your ones complement representation. So binary only I can write, and then I can say this is ones complement representation. It will be same as SMR as well. And even that 2's complement representation will be the same. So for positive numbers, signed magnitude representation, ones complement representation, and 2's complement representation all are same. Okay, sign bit plus 0 copied, and rest of all the bits are 1, 2, 4, 8. Okay, again I am doing it wrong. Again and again I write it wrong. 21 I need to write. 21. So 16, 1, 2, 4, 8, 16. So 21. So 16 would come and 4 would come. Yeah. So 1, 0, 1, 0, 1. That would be the answer. Okay. But if the number is negative, then let's check what will happen. So you need to represent minus 21 in ones complement form. Okay, or ones complement representation. So first task is write down the sign magnitude representation. So negative sign 1 will come. What about 21? 1, 0, 1, 0, 1. Now what you need to do? This sign will be as it is, and you will subtract 1, 1, 1, 1, 1. So you will subtract 1, 0, 1, 0, 1 from this 1, 1, 1, 1. So what you will get? 0, 1, 0, 1, 0. So this you will write here. 0, 1, 0, 1, 0. Okay. But what you can see, sign bit is as it is, and these are the complements of each other. These are simply the inverter ones of each other. So here the second point, what did I write? Keep the sign bit as it is, but take the complement of each magnitude bit. Or you can simply take the complement of each magnitude bit. Now represent plus 21 in ones complement but in 8 bits. How will you do it? What is the sin? Number is positive, so it will be the same as SMR will be equals to ones complement representation will be equals to 2's complement representation. First bit will be of sign bit. Rest all the bits will be used to write down 21. So 5 will be used to write down 21. 21 will be written as this. So 5 bits will be used. So 3 bits will be 0. 1, 2, 3, 1, 0, 1, 0, 1. That's it. Wait a second. 0, 1, 0, 1. Okay, just a second. I am getting. Yeah, so this would be the answer, right? Simply the sign magnitude representation you need to write. That's it. Now minus 21 is there. So what did I tell you? First write the sign magnitude representation. What will be the sign magnitude representation of minus 21 in 8 bits? Sign magnitude representation. So minus will be denoted by 1. How 21 will be written? In 7 bits you need to write 21. 7 bits you need to write 21. So 1, 2, 3 and 5 bits for 1, 0, 1, 0, 1. So this is your 21 and this is your negative sign, right? Now if I am writing ones complement, then this is your ones complement. This is your ones complement representation. So if I am writing ones complement representation, then what did I tell you? This sign bit will be as it is, rest all will be complemented. 1, 1, 1, 0, 1, 0, 1, 0. There you go. Okay. First bit, sorry, this bit as it is, rest all complemented. 1, 1, 1, 0, 1, 0, 1, 0. Are we taking more example? Let's take more example. Okay. Let's take more example. Example is you need to represent minus 37, or we should do minus 28 would work. Minus 28 in ones complement representation. Okay, so in ones complement representation. So first I will write sign magnitude representation. So minus sign 1 would be there. How will I write 28? 28. So 1, 2, 4, 8, 16. 28 you need. So 24 plus 24, 20. So this this would be 1, 1, 1, 0, 0. Right? 1, 1, 1, 0, 0. So yeah. So this is sign magnitude representation, and what will be one's complement? So this one will be copied as it is, rest all will be. So this is the answer in 6 bits. These answers are in 6 bits. If I need to do the same in 8 bits, then what will be the answer? This is the first one. If I need to do the same in 8 bits, so this one will be, sorry, the sign bit 1 will be as it is. Now I need to write 28 in 8 bits. So this 0, 0, 1, 1, 1, 0, 0. 5 bits, these. Now one's complement. This one will come as it is. 0 will be 1, 0 will be 1, 1 will be 0, this will be 0, this will be 1, 1. So this will be represented in 8 bits. Getting the point? Okay. So I hope you are comfortable with sign magnitude representation and one's complement representation. Now this number is given. This number n is represented in wait a second. Yeah. So this number is represented in sign magnitude representation. So which number is that? Number is represented in sign magnitude representation. So very easy question. 1, 1, 0, 1, 1. So this will represent the sign. So minus sign, and this will represent the magnitude. 1, 2, 4, 8. So minus 11. Okay, very easy question. These kind of questions we have already solved. Okay, so this is the answer. Right? Now, this number is given. This is a note. This number is given which is represented in sign magnitude representation only. Now I need to take one's complement of that. It is represented in sign magnitude representation. That means this MSB will be as it is. If I am taking one's complement of that, 1 will be 0, this will be 1, and this will be 0. So this will be one's complement of n. One's complement of n, and n is there in sign magnitude representation. N is there in sign magnitude representation. So it is one's complement of n which is there in sign magnitude representation. Now what if I again take the one's complement? If I again takes the one's complement, one's complement. So this one will be as it is, one's complement. Yeah, one more thing I forgot to tell. If I am saying that this is like in -1, I have taken this one's complement. So this will be considered as a sign magnitude representation as well. Like this one will show the sign only. That's why we are not doing anything. So this one is showing the sign. Okay, this one here shows the sign as well. Same goes for 2's complement as well. This MSB bit will show the sign in 1's complement as well, in 2's complement, or in signed magnitude representation. In all these three things, the MSB bit will show the sign. So this is showing the sign. This one is showing the sign. We will not do anything with that. For rest of them, we will take the complement. 1, 0, 1, 1. So what we are getting? One's complement of a number n in sign magnitude representation, which is equals to the number in, basically this is the same thing we are getting here, right? So if you take 2 times one's complement, you get the same number. If you take that one's complement twice, you get the same number. So I am getting the same number which is denoted in signed magnitude representation. Make sure this number is in signed magnitude representation. So if there is a number which is represented in sign magnitude representation, you take one's complement of that, and again you take the one's complement, you get the same number. Okay, let's solve a problem. Why did I take this problem? Now this number is given. N corresponds to the one's complement of what? So basically this number is one's complement of something. So I need to find which decimal number is that. So what I will do, this number is given. Certainly whether it is 1's complement or 2's complement or sign magnitude representation, always this will be the sign bit. So 1 will be as it is, rest all will be complemented. So now what did I do? I took 1's complement. Here I took 1's complement. 1's complement of n. So this n was already a 1's complement of some number. Now again 1's complement I have taken. That means I am getting the same number now. Are you getting this point? This n was 1's complement of some number. Then again 1's complement I took. That means I am getting the same number. So what is this number? Basically this is the sign, and 1, 2, 4, 8. So this number is minus 11 only. Minus 11 only. Okay. Minus 11. You can write minus 11, 10. So this is the decimal output. You can say this is the decimal output. So basically, if the question was take 1's complement of minus 11, what would be your answer? That, sir, first I will write its sign magnitude, take 1's complement. So first I will write SMR, that would be minus will be as it is. And what about 11? 11 can be denoted as 1, 0, 1, 1. Right? Now I need to take 1's complement. So what I will do? Sign magnitude, sign bit as it is, 0, 1, 0, 0. So this I would get, and this is your n only. So n correspond to the 1's complement of what? So n correspond to the 1's complement of minus 11. So this much you don't need to think. If they are asking whose 1's complement is that, just take the 1's complement again, you will get the same number. Okay, so that's why I took this question. So this is the answer. This is the answer. So if someone is asking you whose 1's complement is that, you can simply take the 1's complement back. Now the following numbers are 1's complement of some number. Which of these numbers are there? So this is 1's complement of what? This bit will denote? Sign bit. This is sign bit. So this is a plus number, 0. So this is 1's complement of plus 0, because SMR for positive numbers, SMR is equals to 1's complement is equals to 2's complement, right? Here positive 1, here positive 2, here positive 3. Now this number is 1's complement of something. This number is 1's complement of something. Of which number it is, that I don't know. So how will I find it? 1 as it is, take complement of 0, 0, it would be 1, 1. So 1 will represent minus sign, 1, 1 would be 3. If the question was take 1's complement of minus 3, how would you do it? You will write 1, and now 1 for this negative sign, and 3 magnitude of 3 will be 1, 1. Then 1 as it is, and complement of these two, 1, 0, 0. That's the answer. So what did I do? Without thinking all these things, what did I do? I simply took 1's complement of this number. So that is minus 3. Now I will take 1's complement of this number, sign bit as it is, 1, 0. So I will write down 1 is minus sign and 1, 0 is 2. So this is minus 2. What about this one? 1 as it is, 0, 1. So this is sign bit minus 1. 1 as it is, 0, 0. This is sign bit minus 0. So here this is your minus 0 and this is your plus 0. So minus 0 and plus 0 both are different things here. Minus 0 and plus 0 both are different things. Okay. So what is the range again? In 3 bits you are again denoting the same number, so the range again is same. What is that range? Minus 2 to the power n minus 1 minus 1 2 plus 2 to the power n minus 1 minus 1. Same as SMR. So range here is same. Here also for 1's complement as well, for 1's complement representation as well, minus 0 is not equals to plus 0. Same was there in sign magnitude representation as well. If we remember, this was the scene. Minus 2 to the power n minus 1 2 plus 2 to the power n minus 1 minus 1. And here also this was the scene. Okay. So same thing is happening here. So this is the range. So these ranges are important. It can be asked. Okay. Let's see 2's complement now, which is also very, very important. So again, what is the method? check if the number is positive or negative. If the number is positive, then answer would be same. If the number is negative, then please turn over. So before that, if the number is positive, what will be the 2's complement representation of this 21? That would be, for plus sign, 0, 1, 0, 1, 0, 1, 21 as it is. So for a positive number, signed magnitude representation, 1's complement representation and 2's complement representation all are same. But for negative number, what you will do? So two method I have written. The same thing goes till here. Till here the same thing goes. Write SMR, keep the sign as it is, keep the sign bit as it is, write 1's complement. After that you add 1 in that. Or what you can do? Write SMR, keep the sign as it is, start writing the bits from the right end as it is until you encounter the first one. Take complement of each bit afterwards. You are not understanding it here. Let's take an example, you will understand it. So now you need to denote minus 21 in 2's complement representation. So what you will do, first you will write down sign magnitude representation. What that would be? Minus sign, 1 would come. 21 would be 1, 0, 1, 0, 1. Okay, let's take 1's complement. What would be 1's complement? So this as it is, 0, 1, 0, 1, 0. Now what did I tell you? After 1's complement you need to add 1. If you add 1, this answer will give you 2's complement. This answer will give you 2's complement. So 1 plus 0 is 1, 1, 0, 1, 0, 1. So that's the answer, which is my 2's complement representation. But every time I will not do this thing. So what I will do? First I will write sign magnitude representation. This is the method 1, I can say. Now this is method 2. So first I will write sign magnitude representation, which is 1, 1, 0, 1, 0, 1. I will keep this bit as it is. This I am writing 2's complement. Directly I am writing now 2's complement representation. Now I will start from the right, from here. I will start from the right end. I will write 1 here. Immediately I got 1. Immediately I got 1. Right? I started from here and I got 1. So after that I will complement all the bits. 1, 0, 1, 0. So I am getting the same answer. Let's just say if my sign magnitude representation is this. If there is the second example. Okay, let's take this example. So my sign magnitude representation will be what? In minus 14. That is 1. And how will you denote 14? 8421. 8421 will be 1, 1, 1, 0. 8421. Yeah, fine. So SMR you have taken. Now directly if I am writing 2's complement representation, or let's write 1's complement representation as well, because we should at least solve two problems with the same method. So 1 will be as it is, complement of each, and then add 1. This will give you 2's complement representation. So 0, 1, 0, 1, 1. That's the answer, right? Oh, sorry, why 1? This would be 0 only. 0, 1, 0, 0, 1. So this would be the answer, right? Now method 2. First I will write SMR. That is 1, 1, 1, 1, 0. Then I directly can write 2's complement representation. How will I write? Sign bit as it is. I will start from here. I am getting 0. Okay. I will wait till I get 1. I am getting 1 now. Yeah, I have got 1. Now after that I will complement all the bits. 1 will be 0, 1 will be 0. Here I did the same thing. I started from here. I got 1 here only. So I will complement all the bits. 0 will be 1, 1 will be 0, 0 will be 1, 1 will be 0. Started from here. I got 0, stayed here. 1, just as I get 1, I will complement all the bits. But sign bit will remain there as it is. Because this shows the sign. This shows the sign. So there you go. This is the way you write 2's complement. Are you getting this point or not? Okay, you are getting the same answer here. You can check. Let's see more problems. Minus 21 in 2's complement representation in 8 bit. So what is the first task? First write in sign magnitude representation in 8 bits. So minus 21 in 8 bits. So 1 would be the sign bit, and 21 in 8 bits, that would be 0, 0, 0, 1, 0, 1, 0, 1. 1, 2, 4, 8. 1, 2, 4, 8, 16. right? 21. So yeah, that's the answer. Now I need to take 2's complement representation. So this bit as it is, I will start from here. Just as I started, I got 1. So complement of all these numbers I will take. That's it. I started from here. Just as I got 1 complement of each number I am taking. 0 will be 1, 0 will be 1, 0 will be 1, 1 will be 0. Again, there is a note. The same thing is there. That 2's complement of 2's complement of 2's complement, sorry, 2's complement of 2's complement of some number, but the number is in sign magnitude representation, you will get the same number. So this note is also there. Okay, let's take more examples. We can take more example of this minus 14 in 2's complement representation in 8 bits. This example we can take. So what will be the sign magnitude representation? That would be 1 would be there. Plus for plus 14 it would be the same. So for plus example we are not taking, only the negative ones example we are taking. So 1 would be there, and these would be 14 can be written in 3 bits, 4 bits only. So 4 zeros will be there, and how will the 14 be written? So 8 4 no 14, yeah. So 1 1 0 1 1 1 0, sorry, this would be 14. And if I need to write 2's complement representation, so 1 sign bit I am keeping as it is. I will start from here. I did not get 1 till here, I got 1. So after that I will take complement of each number. After that I will take complement of each number. That's it. If I need to write 1's complement representation, what I will do? I will see the sign bit only. This sign bit will be there. Now all will be complemented. So first target is to write sign magnitude representation. So all will be complemented now. That's it. Okay. So in that manner we will proceed. Now 1 1 0 0 1 1 0 0 1 and 1 1 1 0 0 1 correspond to 2's complement of what? So all three numbers are there. 2's complement of what? So let's take the first one. 1 1 0 0 1. If I take, so if this number is 2's complement of some number, that means this will denote the sign only. Look, this number is 2's complement of some number. That means if it is a 2's complement, that means certainly this is denoting a sign. So this number is certainly negative. This number is certainly negative. So what I am going to do, I am going to take 2's complement of this number. 2's complement of this number. So this number, this sign will come as it is. I will start from here. I will start from here. Just as I got 1, just as I got 1, I will take the complements, right? So this will denote the sign, which is minus, and what this will denote? This will denote the magnitude, which is 7. So answer is minus 7. Are you getting this point? Let's see again one more problem. This property I am using 2's complement of 2's complement of x. 2's complement of this number is already a 2's complement. Now I am again taking 2's complement of x, but x should be in sign magnitude. So I will get x in sign magnitude. So this x I got, but in sign magnitude. That means this will show the 1 here. So that is the negative. Now this is the question 1 0 0 1. So I will take the 2's complement. How will I take 2's complement? So 1 will be, the sign bit will be as it is. Now this 1 will come here, and then since I got 1, so I will take the complement of 0, complement of 0. So this 1 will denote negative sign, and this will denote 7, right? So answer is minus 7. For this one as well, answer is minus 7. We will notice a very interesting thing here. 1 1 1 0 0 1. What I need to do? I need to take 2's complement, right? The sign bit as it is. This 1 comes here. 1 as it is. Just as I got 1, this will be 1, this will be 1, and these two will be complemented. So this bit will represent the sign. So minus, and this will represent the magnitude. So minus 7. All are minus 7. If the question had been write down the 2's complement of minus 7 in 5 bits, this would be the answer. Write down that 2's complement of minus 7 in 4 bits, this would be the answer. Write down the 2's complement of minus 7 in 6 bits, this would be the answer, right? Okay, all are the same number. Let's take some revision example, so that till now whatever that we that we have studied, that will be your revision here. Till now whatever that we have studied. Represent plus 18 in sign magnitude representation. 18, 1, 2, 4, 8, 16. That will be 1 0 0 0 1. Sorry, 1 0 0 1 0. So first positive sign is there, so 0 will come. Then 1 0 0 1 0. 16 plus 2, 18. For positive number, all these are same. 0 1 0 0 1 0. 0 1 0 0 1 0. Positive number but in 8 bits. So basically this will be 0 and rest all bits. Basically you need to denote 18 in 7 bits. 18 in 7 bits. So 18 can be denoted in 5 bits only, so 2 more 0 will come. And all these are same only. For positive number, all these are same only. So you will not do anything. For positive number, all these are same. But here minus 18, so this one will show the sign and answer will be 1 0 0 1 0. For 1's complement, the sign will be as it is, or start from here. Sorry, sign will be as it is and complement of each 0 1 1 0 1. For 2's complement, sign bit will as it is but start from here. This is 0. This is what? 1. After 1 you will complement everything. 0. That's it. What about this one? Minus 18 in 8 bits. So first one will denote the sign. Now 18 can be denoted in 4 bits only. Sorry, in 5 bits only. So 2 more bits will come. That would be 0, because this will denote the sign, rest all will be the magnitude. 0 0 1 0 0 1 0. So sign will come as it is, rest all will be complemented, right? Rest all will be complemented. 2's complement, this sign will as it is, you will start from the back. This is 0, this is 1. After that you need to take the complements. 0 1 1. So first I will look at SMR, then I can find 1's complement. I will look at SMR, I can find 2's complement. I will look at SMR, I can find 1's complement. I will look at SMR, I can find 2's complement as well. Okay, you just need to look at the SMR and you will find 2's complement and 1's complement both. Now a very interesting thing you are noticing here. Notice the 1's complement in 7 bits. In this 6 bits, and notice 1's complement in 7 bits. Do you notice something? Let me show it. For 1's complement of minus 18 in 6 bit, what was the answer? 1 0 1 1 0 1 1 0 1. For 8 bits, what is the answer? So this sign bit is being repeated only, no? Say yes or no. This sign bit is only being repeated, right? A very interesting thing is about to come. Okay, you will see a proof of very interesting thing. Very, very interesting. Like no one will teach you ever. Okay, so that much interesting thing is there. Now in plus 18, this was the sign bit, so that is being repeated. This was the sign bit, this is being repeated. Minus 18 is 2's complement, so this was the sign bit which is being repeated. This was the sign bit which is being repeated, right? So a lot of sign bits are there. Let's just say 1 1 0 1 1 1 1. So these only 1 is the sign bit which is being repeated. For 1's and 2's complement, this is the sign bit. This is the sign bit. 1 is the sign bit. Now this is being repeated 1 times. Here this is being repeated 2 times. 2 times more basically. Here this is being repeated 3 times more. So what you can do, you can eradicate these, right? Or if someone is asking you, like I have denoted this number in 6 bits. If someone is asking you, denote this number in 12 bits. Write down the 1's complement of minus 18 in 12 bits. So what you will do, you can write it down in 6 bits very quickly, and then rest you need to add 1's. That's it. Just keep on adding 1's, nothing else. So 12 bits, so 3 3 6. Yeah, that's it. This is answer in 12 bits. In 8 bits, if they were asking, so 1 0 1 1 0 I have written. In 8 bits, 2 more. Basically I can cut these two. There is no use of that. Only the sign bit is being repeated. So this thing we have noticed, right? In 2's complement and in 1's complement. This is not true for sign magnitude representation. Only for 1's complement and for 2's complement. Okay, the sign being repeated. So all these are equal only, right? So 2's complement of x is 1 0 1 1 0 0 1 1. What will be 2's complement of x in 12 bits? So what are these bits? 3 3 6 7 8 9 10 11 12. Rest all number will be the same, 1 0 1 1 1 0 1 1. So this is the sign bit which is being repeated. So I repeated it for 4 times. 1's complement of x is this. So what will be 1's complement in 12 bits? So these are 3 3 6 7 8 bits are there. So 8 bits are there. So 1 2 3 4 4 bits I have to use. 1 0 1 0 1 1 0 1. If this one number was 0 0 1 0 0 1 1 1 0, then what would be the answer? So 3 3 6 3 3 9 9 bits are already there. I have to use 3 more bits. So these will only the sign bit I will use. So 0 0 0, 3 more, and then the same number. So for 0 as well it is applicable. Okay, for 0 as well it is applicable. The same sign bit will be there. Same sign bit will be copied. Because for 0 the thing is all representation are same only. 1's complement, 2's complement and SMR. All representation are same. So we need to think of negative ones. So for 0 all representation are same, so that would be very easy. You are writing it for 1 in 7 bits, 10 bit, 12 bit, 13 bit, that would be very easy. But if this becomes long, then you would take complements again and again. So here we are thinking that here we get to know that the sign bit is being repeated. Now 1's complement of x is this, which the number x is in decimal. So what we can do, what we can see here, that 1 1 1 1 1, these are the sign bits only, no? 1's complement of x is this, so these are the sign bits. So that means 1's complement representation is 1 0 1 1 0 1, right? Do you agree to this point? 1 1 1 are being repeated. I can cut it. 1 0 1 1 0 1 in 1's complement is same as this number, right? I told you here this is being repeated, so I can cut it. If I cut it here, 1 0 1 1 0 1 I am getting. Now if I take 1's complement, so how it, again I will take 1's complement to find the number. I told you this 1's complement of x is this. So this number is 1's complement of something. So if I again take 1's complement, I will get to that number. So I am again taking the 1's complement. So sign it as it is. This will be 0 1 0 0 1. So negative sign is there, minus 1 2 4 8 16. So that would be minus 20. 1 2 4 8 16. So minus 18. Sorry. 16. So minus 18. Okay. Is that the same example we have took? 1 0 1 1 0 1. 1 0 1 1 0 1. Okay. The same example we are taking. So basically this is gone. So this answer is minus 18. So this is 1's complement representation of minus 18. Now let's see a very interesting thing. So there is a note which you have to remember. For 0 there is only one representation in 2's complement. In 2's complement, for 0 only there is one representation. It will be the same as 2's complement of plus 0. That means what is the sign magnitude representation of plus 0? So plus 0 will be the sign. Plus sign, if there is plus sign, then 0 will come. And how will you represent 0 in binary? 0 only. Same will be 2's complement and 1's complement, because this is a positive number. For negative number, this for sign 1 will come and 0 will be denoted as 0. Now 1's complement of minus 0. 1's complement of minus 0. So first I will denote it in sign magnitude representation, then 1 as it is, and 1 is the sign, that would be as it is, and I will take complement of 0, that would be 1. Are you getting this point? Sign magnitude representation, if I am saying that this is sign magnitude representation. So how will you take 1's complement? So this 1 as it is and complement of all these, right? So this I am saying 1 as it is, complement of 0, that is 1 only. But minus 0, 2's complement of minus 0. So sign magnitude representation is 1 0, right? Sign magnitude representation is 1 0. If I need to take 2's complement, let's just say I am taking 2's complement with the method that I have taught you. So this sign bit as it is, you start from here. What you are getting directly 0. So your answer is again 1 0. So that means you are saying that both are same, but that's not true. Okay, so this thing you need to remember that zeros are same. That means this would be 0 0 only. So 2's complement representation of minus 0 will be 0 0. So that you need to remember. Okay, so minus 0 is equals to 0 for 2's complement representation, but for 1's complement representation it is not certainly 0. For SMR and 1's complement representation, it is certainly not equal, right? This we have already this. So this is the point that we need to remember. Okay, let's see more interesting thing. So this is the special case in 2's complement which we generally mug up, but here we will see the proof why it is happening. So for minus 4, this number is minus 4. You need to represent it in sign magnitude representation. So how will you represent? Minus sign is there and 4 in 2 bits. What that would be? 4 will be denoted in 3 bits. So this is the sign magnitude representation. Minus sign and then 4. What will be 1's complement? This as it is, complement of rest. What will be 2's complement? This as it is. Start from here. If I start from back side, so 0 0 until I get 1. Here I am getting 1. After that there is no number. So this is the answer. So this is the 2's complement representation of minus 4 in decimal. So this is the 2's complement representation of minus 4. This 1 is being repeated twice, right? What did I tell you? In 2's complement and 1's complement, I can cut these ones if they are being repeated more. So here I can only keep 1 1. This I told you, right? So I can cut this 1 now. I can cut this 1. So if I cut this 1, what will be my answer? 100. So 2's complement of minus 4 is equals to 100 you are getting. Yes or no? In 3 bits only you denoted it. For these you require 4 bits. 4 bits are the minimum. Minimum 4 bits you require. Here also 4 bits you require. You solved with the same process. Let's start from here. 0 0 1 as it is. You solved with the same process. Then you got to know you are getting it in 4 bits. Then but these 2 bits are same. So you can cut it. You get 4. So this is the answer in 3 bits. We will see a very interesting result now. Minus 8. Sign magnitude representation. Negative sign. How will you denote 8? 8 will be 1 0 0 0 1 2 4 8. This will be 8, right? What will be 1's complement? 1 0 1 1 1. This will be 1's complement. What will be 2's complement? Sign bit as it is, start from here. 0 0 0 and 1 as it is. So what you can do? You can cut this one. So 1 0 0 0. What is this? This is in 4 bits only. What about these? This is what our, how many bits are there? 5 bits. And this is 5 bits. So in minimum 4 bits you can represent 8 minus 8. So 2's complement representation of minus 8 is 1 0 0 0. What is 8 2 to the power 3? What is 4 2 to the power 2? So what do you understand here? So this is the special case that if this is 2's complement representation. 2's complement representation. So in 2's complement representation, if you are getting 1 0 0 or 1 0 0 0 or 1 0 0 0 0, these kind of numbers, that means you just need to count the number of zeros, then put the negative sign minus 2 to the power n. That would be the answer. That means it would be the 2's complement of minus 32. Why is that so? I have proved it here. Right? We took the example. We are going from here to here, not from here to here. In all the notes you will find that this is a fact. Everyone will tell that it is a fact, but here we proved it. Where we are coming, where we are getting this from. So if this is the 2's complement representation, so basically this is the 2's complement representation. So number of zeros are 2, then the decimal number will be minus 2 to the power 2. That means minus 4. Here number of zeros are 3. That means decimal number will be minus 2 to the power 3, 8. You can go from here as well. Like if someone is saying that write down the minus 64. You see minus 64. Write down the 2's complement of this number. So you forget that this is a 2's power something. You forget this point. You forget this special property. You have forgotten this. Then how will you solve it? How will you solve it? You will say that, sir, first I will write it in sign magnitude form. So 64 I need to denote. So 1 will be for the sign, and 64 will be 1, 2, 4, 8, 16, 32, 64. So 7. 1, 2, 3, 4, 5, 6, 7. Right? 1, 2, 4, 8, 16, 32, 64. Yeah. So this is my sign magnitude representation, and then I will write 2's complement. So what will be the 2's complement? 1 as it is, and from here 0 I will count. 3, 0, 4, 5, 6, and this one as it is. Now 2 ones are being repeated, I will cut it. So that would be my answer. 1, 0, 0, 0, 0, 0, 0, 3, 3, 6, 3, 3, 6. Right? So this is basically answer minus 2 to the power 6. So what is 64? That is minus 2 to the power 6 only, no? So 6, 0 you can add. So directly I can come. So basically from here to here it will not be that tough. But in the examination, if this is coming, then you should directly click to me. Okay, 6 zeros are there. So it is the 2's complement of minus 32. That's it. Okay. Let's see the next question. In the next question, what is there? This number n is there. X is signed magnitude representation of n. You need to find the value of x. It is signed magnitude representation. Signed magnitude representation. That means first will show negative. 1 will show negative, and this will show the magnitude. What is that? Minus 0. What will be the answer of B? N is 1, 0, 0, 0, 0, which is 1's complement of something. So what you can do? You can take again 1's complement. So 1 will be 1 as it is, and 1's complement of this will be 1, 1, 1, 1. So what you are getting? This 1 will be for minus sign, and what is 1, 1, 1, 1? That is minus 15. So y value is minus 15. This is your x value. X value is minus 0. X is a sign magnitude representation of n. So in sign magnitude representation, you don't need to do anything. First one will be your sign bit minus 0, 0, 0 will be 0. In 1's complement representation, you need to take 1's complement. Again, you need to take 1's complement. So 1 as it is, I again taken the 1's complement. So this is showing me the sign minus, and this will be 15. What about the third one? 1, 0, 0, 0, 0. What I will do? If this is 2's complement representation, if I again go on taking the 2's complement, I will get the same number. If I take 2's complement of this, what I will do? I will get the same number. 1 I will keep as it is. I will start from here. I will get the same number. I am not going anywhere now. I will say this is minus 0 because this sign is 1, and I will say that this is 0, so I will say minus 0, which is wrong because I told you one thing, the plus 0 and minus 0 is same in 2's complement. So this cannot happen. That means this is the special case. So here there are how many zeros? 4 zeros. This is minus 2 to the power 4. So answer is minus 16. This is the case of minus 16. That means this is 2's complement representation of minus 16. This is the value of z. Minus 16, 10 you can write. Here also 0, 10 you can write. This is the 2's complement representation of minus 16. Okay. Now the following numbers are 2's complement representation of some number. You need to find those numbers. So for positive numbers it would be all same. 1, 0, 0 it would be minus 2 to the power 2. That would be minus 4. Right? Are you getting this point? 1, 0, 0 will be minus 2 to the power 2 minus 4. What about this? Again take 2's complement. So 1 as it is, this 1 as it is, and this 0 will be 1. Basically 1 as it is, sign as it is. 1, 0, 1. I need to take 2's complement of that. Because these are the 2's complement of some number. So I need to find 2's complement of this number again to get the same number. This we have done like 15 times in this lecture, right? So 1 as it is, this 1 will be copied. Since I got 1, this will be 1. I will take the complement. So I will start from 1 as it is. I will start from here. I got 1 here only. I will start 1 as it is. I will start from here. Since I got 1, I will take the complement. Okay. These are the 2's complement. So basically minus sign minus 3, minus sign 2, and minus sign 1. So what is the range? For 3 bits, what range we are getting? Here this negative sign is increased, minus 4 to 3, because minus 0 is equals to here plus 0. For 0 there is only one representation. So both are same here. Okay, it could be equals to minus 0 as well. Both are same here. That's why the range has increased, minus 4 to 3. So what would be the range here? Minus 2 to the power n minus 1 to plus 2 to the power n minus 1 minus 1. Right? For 1's complement, what was the range? Minus 2 to the power n minus 1 minus 1 to plus 2 to the power n minus 1 minus 1. For sign magnitude representation, what was the range? Same range. Here, one digit has increased in negative direction. So that's why minus 2 to the power n minus 1 minus 1 plus 1. So it would be minus 2 to the power n minus 1 to plus 2 to the power n minus 1. Let's write it in a table. So if there are 3 bits, 3 bits means total 8 possible combination. 2 will be 0. So divided by 2, 6 by 2. Basically we will start from minus 3 to plus 3. So it will go from minus 3 to plus 3. If there are 4 bits, total combination 16. 2 will be 0 divided by 2. So 8 by 2 we are getting 4. 8 by 2 we are getting, 14 by 2, 7. So minus 7 to plus 7. What about n? Minus 2 to the power n minus 1 minus 1 to plus 2 to the power n minus 1 minus 1. 1's complement representation, same. Okay. The range is same, right? The range is same. Okay, sorry. 2 to the power n minus 1 minus 1, 2 to the power n minus 1 minus 1, minus 2 plus. And for here, minus 4 to plus 3, it would be minus 8 to plus 7. So this would be minus 2 to the power n minus 1 to plus 2 to the power n minus 1 minus 1. There you go. Okay. So these formulas you need to keep in mind. You don't need to mug it up. If concept is clear, you will keep in mind. So this was the representation of signed number. We saw SMR, 1's complement and 2's complement. I hope you are not confused and everything is crystal clear. In the next lecture, we are going to see the arithmetic operation. Just like arithmetic operation we have seen in the codes, the same kind of arithmetic operation we will see in 1's complement and 2's complement as well. And there will be a very important concept, that will be the concept of overflow. So next video will be our last video of this chapter, and that would be very, very important. Okay then? Yeah. So let's meet you in the next video. Hi everyone. So in this video we are going to start studying about complement arithmetic. So like the previous video, in this video as well, I want your full attention. Just give me your full attention for next 1 hour and you will be able to understand this topic. Otherwise this topic becomes very complex. You can ask a lot of students, they will say that this topic is pretty complex. But you give your full concentration and you will be able to solve all the problems just for next 1 hour. Okay. So we have done BCD calculation, right? We have done XS3 calculation. So there was a certain method. So here also there will be a certain method. So 1's complement arithmetic you need to do. So what you need to do? First you need to represent the number in 1's complement form. First you need to represent it in SMR, then you need to represent it in 1's complement form. Then just perform the binary addition. Same kind of thing we did in our previous calculation as well. In BCD addition, what we did? We represented the number in BCD and then we did the binary addition. Same thing we are doing here. Now, there are two things. If carry is generated, if carry is not generated. If carry is not generated, then it is fine. If carry is generated, then you will add that carry. That's it. Add that carry to the result. Okay. And if you add that carry to the result, answer will be in 1's complement form. Because why answer will be in ones complement form? In both of the cases, answer will be in ones complement form only, because you are converting the number in ones complement and then you are performing the addition. So answer will be in ones complement form only, no? Are you getting this point? When we were doing the BCD calculation, answer was in BCD only. When we were doing XS3 calculation, answer was in XS3 calculation only. Answer was in XS3 numbers only. So similarly, if you are doing the ones complement calculation, the answer will be in ones complement only. Okay. Now these points you might not be able to understand as of now, but let me just spend some time, then we will come back to these points. Okay, we will come back, we will spend some time here, then we will come back. So tell me this point, this you see this line, if answer is positive, and if answer is positive, you perform the addition, your answer is positive. If answer is positive, then can I say that my answer is in, if my answer is in ones complement form, then can I say that this answer is in normal form only, if answer is positive. If my answer is coming positive, that means my ones complement form, sign magnitude representation or normal form, all will be same, right? How you represent 13? Not let's take the example of 7. How you represent 7? 1 1 1. How you represent plus 7 in sign magnitude representation? 0 1 1. How you represent plus 7 in ones complement representation? 0 1 1 only, right? For positive number, all are same. That means if my answer is coming positive, that means I can say that my answer is in normal form, or you can say it is in ones complement form, or you can say it is in sign magnitude representation, or you can say that it is in twos complement form, right? You can say anything if your answer is coming positive. And generally, if your carry is generated, then answer will be positive, and if your carry is not generated, then answer will be negative. But you need to make sure that you are performing the addition using minimum number of bits. Now what is the meaning of minimum number of bits? That we will see through the examples. So if you are performing the operation using minimum number of bits, then this thing is certain. Which thing is certain? That if carry is not generated, then answer will be negative, and if carry is generated, then answer is positive. How will you remember it? If carry is generated, something is generated, that means you have done something. If something is generated, that means you have done something positive, so answer will be positive. If nothing is generated, that means you have done nothing in your life. If you have done nothing, that means you are negative now, so answer will be negative. This is how you can remember it. Okay, although it will come to you on its own when you perform the calculation. So for as of now, you just need to take care of this thing, that first you need to represent in ones complement form, then you need to perform the binary addition, and then if carry is generated, you just need to add that up. That's it. You can forget about these things. Okay, just forget about these things. And this thing also you need to take care. If answer is coming positive, then I can say that it is in normal form, or it is in sign magnitude representation, or it is in ones complement representation. Let's perform this addition. So we know 26 minus 14 will be 12. That we know, but we need to perform it using ones complement representation. So can I write it in this manner, that it is plus 26 plus minus 14? Say yes or no, and the answer will be coming there. I can write it in this manner, right? Plus 26 plus minus 14. So what will be the sign magnitude representation of 26? Sign magnitude representation of, because you need to write ones complement representation. So first you will write sign magnitude representation, right? You need to write ones complement representation. So first you will write the sign magnitude representation. What that would be? 26, 12, 13, 0, 2, 6, 1, 2, 3, 0, 2, 1, 1. So 1, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 0. This 0 bit is for sign, and I can write 1, 2, 4, 8, 16, 32. So 2, yeah, 26. Yeah, that is fine. Just a second, let me turn on the charger. Okay, I will come. Just one sec. Yeah. So till then you can write down the ones complement representation. So it would be the same only. Ones complement representation of plus 26 would be the same. It would be 0 1 1 0 1 0, because it is a positive number. What about sign magnitude representation of 14? Minus 14. That would be, first one is the sign bit. What about 14? 1 2 4 8. You can represent it like this, right? But this number is in 6 bits, right? This number is in 6 bits. So here also I will take 6 bits only. So 1 0 I will put here, and 1 1 1 0. Why I put this 0? Because these were total 5 bits, so and 1 is sign bit, 5 bit magnitude bit and sign bit. So here also I would need the same bit, so because I need to perform the addition, no, that's why. So equal bits I will keep. Now now what will be 1's complement representation? 1's complement representation of minus 14 would be sign bit as it is, rest all inverted. Now you have 1's complement of 26, you have 1's complement of 26, that is this, and you have 1's complement of minus 14, 1's complement of minus 14. What you need to do, you need to perform the addition here now, because the sign is of addition, just perform the addition. If you perform the addition, what you will get? 1 1 0 1 0 0 1, just binary addition I am doing. Now this one will go here, because if carry is generated then 1 will be added. Now add it up. 1 plus 1 is 0 1 0 1 1 0 0, that's it. This is the final answer. So what is this? You can check it directly, it is plus 12. And what did I tell here? If carry is generated, answer will be positive. Carry is generated, answer will be positive. You can see, if carry was generated here, if carry is generated, then answer is positive. So how can we remember it? If carry is generated, that means I have done something in my life. Carry is generated, I am generating something. That means if I am doing something, that means answer will be positive. One thing more, this thing will work only if we are using the minimum number of bits. So here minimum number of bits, these much bits were required, right? To represent 26, these much bits were required. Although here we used one extra bit, this was not required, still we used one extra bit. This is extra bit only, no, I can cut it as well. But these are the minimum number of bits. Like here you required 6 bits, and here you required, in this one you required 6, and in this one you required 5 only, but you represented it in 6 bits only. Why you represented it in 6 bits? Because you need to perform the addition. If you are represented it in 5 bits as well, then also like then you would not be able to perform the addition correctly, no? Like all the bits should be the same, number of bits should be the same. But what if, so maximum of these are 6, so 6 bits are required. But what if I had represented this number in 7 bits? Then this carry, if I had represented this number in 7 bit, then this thing would not work, that carry is generated or carry is not generated. We will see those examples. Okay, we will see those examples when we will represent the numbers in more bits, and this concept will not work there. So this concept will work only if you are using the minimum number of bits. Then if carry is generated, your answer will be positive. If carry is not generated, then answer will be negative, and you will be able to remember that. So on a top level, I hope you are understanding what all you need to remember and how you need to perform the addition. So try doing it on your own. So how you can write this one? Plus 14 plus minus 26, right? This is what you need to do, and you will get your answer. So what is 1's complement representation of plus 14? Because directly we can write, since this is a positive number, so I will directly write it. So plus 14, that would be 0 0 1 1 1 0. Why I am writing two zeros? Because I know for 26 I would require 6 bits, so that's why I am representing it in 6 bits only. Now what will be the sign magnitude representation of minus 26? What that would be? Sign magnitude representation of minus 26. So first bit is 1, rest all are 1 1 0 1 0. What will be the 1's complement representation of minus 26? So sign bit as it is, rest all complemented. Okay, so what we need to do? Plus 14 plus minus 26. We need to add these two, plus 14 and plus minus 26, that is 1 0 0 1 0 1. अरे यार कितने नोटिफिकेशन आएंगे, वेट अ सेकेंड. So just add them up, 1 1 0 0 1 1. Carry is generated? No. If carry is not generated, that means, what does that mean? Yeah, here one more thing I forgot to tell. Here this answer is in 1's complement form only, but 1's complement form is equals to sign magnitude representation, because the answer is positive. Here this answer is coming in 1's complement form only. This answer is in 1's complement form, but the sign bit you can see that this answer is negative. So this answer is in 1's complement form. This is your answer, but you need to check whose 1's complement is that. you need to check whose 1's complement. If you convert this into directly the number, so it would be 1, 2, 4, 8, 16. So 16 plus 3, 19. You are getting minus 19. So you will say that the answer is wrong. Answer will be minus 12. No, this number is represented in 1's complement form of your answer. 1's complement representation of your answer. So if they are asking perform the addition and write down the final answer in 1's complement form, then this would be the correct answer. And if they are asking write down the final answer in sign magnitude representation, you got some answer, you got this answer in 1's complement form. Now if they are asking that you need to write down the final answer in sign magnitude representation, then what you will do? I told you this thing. If I need to get the sign magnitude representation again, then what I will do? I will again take 1's complement. So again taking the 1's complement. So I will again take 1's complement. Again take 1's complement. So if I am again taking 1's complement, so 1 will be there as it is, 0, 1, 1, 0, 0. So this answer is in sign magnitude representation of your answer. Sign magnitude representation of your answer. And you can check it. What will be the sign? Since 1 is there, so minus sign is there. 1, 2, 4, 8, minus 12. That's it. The answer is correct. So I will again repeat all the things. Within 2 examples, we are understanding everything. So first we wrote with respect to sign and we performed addition here. So this is the addition. Okay. Now plus number is there. So sign magnitude and 1's complement are same. Minus 14 is there. So I represented it in 1's complement. Then I performed the addition. I got a carry. I added it up. Then this is the final answer I am getting. Now this final answer is in 1's complement form only because we have performed the 1's complement application. 1's complement we have performed the 1's complement addition. So final answer is in 1's complement representation only. But since this answer is positive, then 1's complement representation will be equals to the sign magnitude representation. That means both are same. Or you can say normal form as well. You can call it normal form as well. That in normal form as well you will get this answer only 1, 1, 0, 0. How you will represent 12 number 12 in binary 1, 1, 0, 0 only. So if your answer is being positive, then you can say that my answer is in 1's complement form, or it is in sign magnitude representation, or it is in normal form. So answer is plus 12. So if you are performing a 1's complement arithmetic, then your answer will be in 1's complement only. So here I performed the same thing. I got the answer, and here this answer is in 1's complement representation. So if they are asking me, you need to write down the final answer in 1's complement representation, then this would be the answer. But if they are asking me, you need to write down the final answer in sign magnitude representation, then this would be the answer. Okay. So if this they are asking, then I would write this answer. Sign magnitude representation and 1's complement representation. And another thing we got to know here is that if carry is generated, then my final answer is positive. If carry is generated, that means if I am generating something, I have done something positive, so my final answer is positive. And if there is no carry generated, then my final answer is negative. So this answer is coming out to be negative. This answer is coming out to be negative, which is minus 12. So this much thing is there in 1's complement representation. And if I have mixed all of these things, then you would be confused. But here every single thing is clear. Every chart is clear. Okay, first this chart is there, how we are performing. Then this chart is also there. So now everything we have broken down and things are clear. Now we need to study 2's complement arithmetic, and it is the same thing. We are doing the same thing, exactly the same thing. We will represent the number in 2's complement. Okay, we will represent the number in 2's complement. We will perform the binary addition. If carry is not generated, we will not do anything. If carry is generated, we will ignore the carry. Only difference is if carry is generated, you will ignore the carry, and result will certainly be in 2's complement representation because you are performing the 2's complement arithmetic. So in 1's complement representation we add the carry, in 2's complement representation we ignore the carry. So how will you remember it? Like people get confused, sir. Okay, in 1's complement we need to ignore it or we need to add it. So how will you remember it? So what will be your carry? Carry will be 1, right? Your carry will be 1. If you are doing 1's complement arithmetic, you are doing 1's complement arithmetic and your carry is 1. Both are similar, no? 1 and 1. If both are similar, that means they will fight. They will fight means you need to perform the addition. Here it is. You are doing 1's complement representation and you are getting carry 1. Both are similar, they will fight and you need to add 1. What about 2's complement representation? Your carry is 1 and you are performing 2's complement representation. So 2 guy is greater. 1 came to fight, but 2 is greater. 2 is greater than 1. So he will say, I will ignore you. If greater guy is there, he will ignore. If equal guys are there, they will fight. If you are greater than someone and he is coming to fight you, then what you will say? Just stay there, kid. Okay, if some 4-year-old guy coming to fight with you, then what you will say him? Just stay there, kid, I will ignore you. So similarly, 2's complement will ignore the carry and 1 will fight. अब अगर कोई 22 साल का आएगा वो बोलेगा लड़ते हैं, तो फिर लड़ोगे आप, हाँ. Okay, so this is just a way to remember it. So let's start. The same things are written. If answer is positive, then we can say it is 1's complement representation. Sorry, here I should have written 2's complement representation, or you can say it will be equals to 1's complement representation as well. So you can say it would be equals to 2's complement representation or sign magnitude representation or in normal form, right? And if you perform the addition using minimum number of bits, then if carry is not generated, then answer would be negative, and if carry is generated, that means you have done something positive in your life, the answer will be positive. So that's the same thing. The slide is completely same. We just copied the slide, nothing else. So only difference is here is this. This is the only difference. Otherwise, all the things are same. Every single thing is same. Just only difference is this. You need to ignore the carry here, and here you are adding the carry. That's the only difference between 1's complement arithmetic and 2's complement arithmetic. So let's take the same example and solve it. So what will be the sign magnitude representation? So how I can represent it? So I need to perform 2's complement arithmetic. So how will I represent it? Plus 26 plus minus 14. So what you will get? So plus 26 in sign magnitude representation, it would be the same in 2's complement representation as well. So what would be 26? Here we have written, right? 0 1 1 0 1 0 110 10 0 1 1 0 1 0. What it would be? Plus 26 in 2's complement representation, 0 1 1 0 1 0. What about minus 14? Minus 14 in sign magnitude representation, that would be 1, and we have written 14 here. 0 1 1 1 0 0 1 1 1 0. And what it would be? Minus 14 in 2's complement representation. What that would be? So this one goes here. We will start from the back. 0 1. This would become 0 0 1. Since I got 1, rest all will be complemented. Okay. So that's the thing. So this is our 2's complement representation, and this is our 2's complement representation. Now what we need to do? We need to perform the addition. So in these kind of problems, always you will go step by step, and you will never be in a hurry. You will solve the questions with the patience. If you are solving it with the patience, you will get the correct answer. Otherwise, there would be an issue. So this would be 0 and 1 carry. So the addition I have performed. 0 0 is 1, 1 1 is 0, 1 1 goes here, 1 plus 0 is 1, 1 plus 1 is 0, 1 carry, 1 plus 1 is 0, and 1 carry. So this carry I will ignore. This carry is ignored. So what is the answer? This is the answer. So this is the answer, which is plus 12. You can directly see the answer is plus 12. And if carry is generated, your answer is positive. And you are performing the addition using minimum number of bits. This was 6, this was 5, but we will denote it in 6 only. So what is the maximum of 6 and 5? That is 6. So 6 bits if you are using, but if you are using more bits, then the answer could be different. Then sorry, the answer would be same. If you are using more bits, the answer would be same, but the concept that carry is generated, carry is not generated, that concept will not work. So that concept will work if you are using only the minimum number of bits. Okay, if you are using more bits, then that concept will not work. So generally we will perform the addition using minimum number of bits only, because why should we increase the size? If you are increasing the size, that means you are using more bits, that means you are using more size. So we will not do that. Let's start here. 2's complement representation. So what will be the 2's complement representation of plus 14? Plus 14. That would be this. So okay, plus 14. Sorry. Plus 14. Plus 14 would be 0 0 1 1 1 0. That would be plus 14, right? Because it will be the same as sign magnitude representation. So this sign bit will be 0, and 0 1 1 0 will be same. Now minus 26 in sign magnitude representation. What that would be? So 1 as it is, 1 1 0 1 0, and in 2's complement representation, what that would be? Minus 26. 1 here as it is, 0 1 1 0 0. So that would be in 2's complement representation. So if you perform the addition, what you will get? 0 0 0 0 1 1 1 0 1 0 0 1 1 0 0 0. 1 goes here, 1 1 1 would be 1, 1 goes here, 1 1 would be 0, 1 goes here, and 1 goes here. So what you are getting? Let me check back the calculation again. 0 0, 1 goes here, 1 goes here, 0 1 1. Okay, so this answer you are getting. This was also in 2's complement form only. This was also in 2's complement representation, but it would be equals to the sign magnitude representation since the answer was positive. Now this answer is also in 2's complement representation. This answer is in 2's complement representation, but here you cannot say it is equals to sign magnitude representation, because in 2's complement representation, if first bit is 1, that means this shows negative. So your answer that is coming out to be is 1 1 0 1 0, which is in 2's complement representation. So I need to find it in sign magnitude representation. So what I will do, I will again take that 2's complement. So this will be as it is 0 0 1. Now all bits are complemented. So this is my sign magnitude representation, and you can directly see it is first bit is of sign, so minus, and 1 1 0 0, that is 12 only. So this is the answer you are getting. So I hope the things are clear, how to do 1's complement calculation and how to do 2's complement calculation. I hope the things are clear to you. Okay, let's see a revision question. This will be a complete revision problem. You need to perform the given operation using 1's complement representation and 2's complement representation. So first you will need to denote it in sign magnitude form, 1's complement form, and 2's complement form. Positive number is also there, negative number is also there. So first you need to denote that, and then you need to perform the addition. So that will be the revision of the previous chapter. So you should be doing it on your own. Previous chapter, I have told you how to represent 28 in sign magnitude representation. How to do it? It would be plus 28. So directly 0 and then 28. What about 1's complement? Let me check it is correct only. 1 2 4 1 2 4 8 16. So 28, yeah, right. Same will be for 1's, same will be for 2's, because this is a positive number. Same goes for 12. This is your 12. Same for 1's, same for 2's. For minus 28, first bit will be 1, rest all the magnitude bit. If you take the 2's complement, so sorry 1's complement, then what you will do? Complement each bit, and sign bit will remain there as it is. Here also sign bit will remain there as it is. We will start from here 0 0 1. Since I got 1, rest all bit will be complemented. So 0 0. Same goes for minus 12. So 1 you wrote, 0 1 1 0. These are the magnitude bits. So 1's complement, if you take, this sign bit remains there as it is, and rest all complemented. For 2's complement, sign bit remains as it is. You will start from the back 0 0 1. 1 will be complemented to 0. 0 will be complemented to 1. Why we are doing so? Because since we get 1, after that we need to complement it. That's it. So this we have already studied in the previous lecture. So you should be able to do it on your own. Let's move towards the calculation. So first we will do 28 plus minus 12. So first one is 28. So plus 28 we can say, plus 28 plus minus 12. Okay. So this we need to perform. So now let's solve the first question. So this is the first problem. Plus 28 minus 12. Plus 28 minus 12, that means plus 28 plus minus 12. Okay. So let's solve it with 1's complement representation. So how will you solve it? How will you denote plus 28? Plus 28 in 1's complement, that is 0 1 1 1 0 0, and minus 12 in 1's complement, that is 100 0 11, 110 0 11, 110 0 11. Now what I need to do? I need to perform the binary addition. Binary addition I can do. So although answer I know that would be 16. Answer is 16. That means answer is positive. If answer is positive, that means carry should be generated. So let's see if carry is generated or not. 1 1 1 1 0 0 and 1. Yes, carry is generated. And if carry is generated, what do? We add it up. So now we will get the final answer. 0 0 0 0 and finally 1. So this answer is in 1's complement form only, because we have performed 1's complement, we have performed 1's complement addition. So answer will be in 1's complement form only, but since the answer is positive, we can see the sign bit. We can see the sign bit. Since the answer is positive, then we can say 1's complement representation will be equals to sign magnitude representation, or you can say it is equal to the normal form. So you don't need to do anything now, you can directly check this number is, since it is positive, so positive you are getting, and here 1 2 4 8 16 plus 16, that's the answer. Now let's do it in 2's complement representation. Okay, so 2's complement of plus 28 will be the same as 1's complement. And what about minus 12? That would be 110 110 100 110 100. Let me check it back. 110 100. Now you need to perform the addition. Answer is positive, then what do you think? Carry should be generated. So if carry will be generated here, but if carry is generated, what I need to do? I need to ignore this carry. So after ignoring this carry, what is the final answer we are having? This is the final answer we are having, and here you can see what is the sign bit. Sign bit shows that it is positive, although the answer is in 2's complement representation, but since the answer is positive, you can say it is equals to the sign magnitude representation, or you can say it is normal form. Okay, so what is the answer? You can see plus 1 2 3 4 5. So 2 to the power, sorry, 4 zeros are there, no? So 1 2 4 8 16. So answer is plus 16. So that's it. Okay, so this we have done. Next you need to do it on your own, then only you should see the solution. Will I be able to do on this page only? 12 minus 28 plus 12 plus minus 28. Do it on your own, then see the solution. So plus 12 will be represented as 00 11 00 00 11 00 minus 28 in 1's complement 1 000 11 1 000 11. What will be the answer? Answer will be negative. I can see 12 minus 28, answer will be negative, but if answer is negative, that means carry will not be generated. So 1 1 1 1 0 1, carry is not generated, but this answer is in 1's complement representation. So if they are asking write down the final answer in 1's complement representation, you will stop here, this would be the answer. But if they are asking what will be its sign magnitude representation, what will be its sign magnitude representation, so what you will do, you will again take 1's complement. So 1 here as it is 1 0 0 0 0, again I am taking 1's complement, so I am getting the sign magnitude representation. So this is the sign magnitude representation of this particular number, which we can see first bit is the sign bit, so minus, and rest all the magnitude 1. So answer is minus 16, right? Let's perform it using so yeah, so this was 1's complement, now we will do it with the 2's complement. So plus 12 will be 0 0 1 1 0 0. What about minus 28? So 100 100 100 100. We need to add them up. Since I know answer would be negative, so I should not generate any carry here. Carry would not be generated. Yes, carry is not generated. So this is the answer. So this is in 2's complement representation. Whose 2's complement representation is that? Can you tell me? Whose 2's complement representation is that? This is of minus 16. Why so? Do you remember the special case? If this is written, can I do this thing? I can remove it, because 1 1 twice is being repeated. Here it was not repeated. Here it is twice being repeated. So whose 2's complement is that? Whose 2's complement is that? Do you remember the case? That is minus 2 to the power 4, right? 1 2 3 4 minus 2 to the power 4. So this is the 2's complement of minus 16. Otherwise, if you don't even remember the case, how you would do it, you would get 2's complement of that, because this answer is in 2's complement representation. If you need sign magnitude representation, then what you would do? You would get again 2's complement, right? If I need in sign magnitude representation, so what will be the 2's complement of that? It would be same only. It would be same, right? Because you will be keeping the sign bit as it is, and you will start from here 0 0 0 0 and 1. So if you take 2's complement, you get this number, which is in sign magnitude representation. Because if you take that 2's complement of a 2's complement number, then you get the same number. So here 1 will show the sign, and rest of bits will show the magnitude. That would be minus 16. So here also you are getting the same answer. But the special case we usually remember, that is minus 2 to the power 4. Are you getting this point? Understandable, right? Okay then, so this is the answer, that is minus 16. So this we have done, and this is also separated. Okay, so yeah, this was a revision question. Everything is being revised here. Special case is also revised, and those normal cases are also revised. Everything is revised. Now, concept of overflow will come. So that is the most important concept. But first we will solve some problem, then we will understand what is the meaning of overflow. So forget about the overflow thing. Don't even look at the heading. Solve these problems using 2's complement representation. You can solve it on your own. Very basic thing. Plus 5. How that will be represented? 0, 1, 0, 1. Using 2's complement representation. Yeah. Concept of overflow will occur in 2's complement representation only. Why so? Because it has something to do with the carry. Concept of overflow has something to do with the carry, that we will see. And carry, if carry is there in 1's complement, that is added. But here we are ignoring it. So that's the reason it will occur in only 2's complement. Here we are doing something with the carry, no? But here we are not doing anything with the carry. So that is the reason we will get some calculation wrong. How we will get the calculation wrong? How we can make it correct? What is the concept of overflow? That we will see. But it will occur only in 2's complement representation, not in 1's complement representation. Okay. So how will you denote 5? 0, 1, 0, 1, right? How will you denote 6? So 6 in sign magnitude representation will be 1, 1, 0, right? Because 1, 2, 4. 6 in sign magnitude representation. And how will you denote minus 6? So 1, 1, 1, 0. Okay, so sign it as it is. And now what you need to do? You need to take 2's complement. So 0, 1, 0. That would be the 2's complement of minus 6. First I represented it in sign magnitude representation. That would be 1 for the sign and 1, 1, 0. And then we need to take keep the sign bit as it is and start from here 0, 1 and take a complement of that, since you have got 1. So 1, 0, 1, 0. Till now you should be comfortable with all this. You should be comfortable with all these kind of things. Since I know answer would be negative, 5 minus 6, answer should be negative. So if answer is negative, then carry should not be generated. Let's check if we are getting a carry. No, we are not getting any carry. So this is the answer we are getting. So this answer is in what? Certainly the answer will be in 2's complement representation. So this is the answer. If we need to get sign magnitude representation, then we again need to take 2's complement. So what that will be? 1 as it is, start back from here. This one will be complemented, this will be complemented. So answer is what? You can see first bit is for sign and rest bit is for magnitude. So magnitude is 1 and sign bit is 1. So minus 1. So that's the answer. Okay. Look, if we have directly studied these topics, it would be very complex. Now you might seem this is easy, but if you study on all those together, then it would be very difficult. But we are breaking down all the things, so it becomes easy for you. So I hope this answer is correct. So what we got? Correct answer. We got correct answer. Here we got the correct answer. We performed the addition using 2's complement representation. We got the correct answer. Minus 1 here, minus 1 here. Let's do this. 6 minus 5. So 6 in sign magnitude, that would be this. And minus 5 in sign magnitude would be this. And what would be the 2's complement? That would be 1 as it is. 1, 1, 0. This will be 2's complement. 1, 0, 1, 1. That would be 2's complement. Need to add them up. So 1, 0, 0 and 1. Carry is being generated. Ignore the carry. Ignore the carry. Now this is your final answer, which is in 2's complement form only. But since you can see sign bit is 0, that means this 2's complement representation is equals to sign magnitude representation only. So answer will be plus 1. This will show the what? This will show what? Sign, and this will show the magnitude. So plus 1. That's the answer. So plus 1 here. Correct answer we are getting. Again we are getting the correct answer. Right? Till now there is no problem. Let's solve this one. 6 plus 5 is equals to 11. That we know. You need to solve this problem, but using 4 bits. I am telling you need to solve it using 4 bits. So what will be the representation of 6? That would be 0, 1, 1, 0 in 2's complement, because it would be same as sign. And what would be the representation of this? 0, 1, 0, 1, because both are positive numbers. So for both sign magnitude representation and 2's complement representation would be the same, right? Just add them up now. 1, 1, 0 and 1. Carry generated. Is carry generated? Forget about carry now. Now this is your answer, which is in 2's complement representation. I told you answer will always be in 2's complement representation. You are performing the 2's complement representation. You are performing 2's complement arithmetic. So answer will be in 2's complement only. Carry is not generated, so you know the answer should be positive. But what do you see here? This is in 2's complement representation. Now you need to get the correct answer. If you need to get the actual answer, that means you need to convert it into sign. This answer is in 2's complement representation. So you need to convert it into sign magnitude representation. How will you convert it? By taking the 2's complement again. So 1 will be remaining there as it is. 0, 0 and 1. What does this show? Negative sign. What does this show? Magnitude. What is the magnitude? 1, 2, 4. The magnitude I am getting is 1, 2, 4. Sorry. I am taking 2's complement. Really sorry. How would I take 2's complement? So this one as it is, this one will be copied and rest 2 will be complemented. So 1, this as it is, minus sign. 1, 0, 1, 1, 2, 4, minus 5. So what you got as the answer? Minus 5. And this answer is incorrect. Because answer should be 11. What we did, we did the same thing. Using 4 bits, we did the same thing. And then answer will be certainly in 2's complement form. Whatever the answer that you are getting, that has to be in 2's complement form only, because you are performing the 2's complement addition. Here I always told that answer will be 2's complement in form only, but since the answer is positive, it would be equal to SMR. So this answer is also in 2's complement form. You need to take the sign magnitude representation now. So you need to get the sign magnitude representation. Then what you will do? You will take the 2's complement again. So if I take the 2's complement again, what I am getting? Sign bit as it is, and then start from here 1, 0, 1. This number I am getting. So what is this number is represented in sign magnitude representation. So what is that number? This number is minus 5. So answer you are getting is minus 5, but actual answer is 11. So this answer is wrong. Incorrect answer you are getting. Why that happened? Why that thing happened? We will check it. Or shall I tell it now? Why that happened? Because you are having 4 bits, no? You represented the number in 4 bits. So range of numbers in 2's complement representation using 4 bit. What is that? Using 4 bit, what is the range of number you can represent in 2's complement representation? That would be 2 to the power 4 minus 1 minus 2, 2 to the power 4 minus 1 minus 1. So that would be minus 8 to, here plus sign will be there, minus 8 to plus 7. So using 4 bits you can get these numbers, right? Using 4 bits from minus 8 to 7. And here you need to represent the number in 4 bits only. So if you are representing that number in 4 bits, what is the answer you are getting? Answer is your plus 11. But you cannot represent plus 11 using 4 bits. Using 4 bits, you cannot represent plus 11 in 2's complement representation. That's why you are getting your wrong answer. That means plus 11 and minus 11 does not lie in this range. So using 4 bits doing this calculation is impossible. Doing this calculation using 4 bits is impossible. So that's why you are getting the wrong answer. Here also you will get the wrong answer. Try doing it on your own. So minus 6 in 2's complement form. What that would be? 1, 1, 0. So 0, 1, 0, 1. 1, 0, 1, 0. And what would be minus 5? 1, 1, 0, 1. So 1, 1, 1, 0. So 1, 0, 1, 1. And if you perform it, 1 plus 0 is 1, 0, 1, 0, and carry is generated. So if carry is generated, you will ignore it. What is the final answer you are getting? What is the final answer you are getting? Here you can see 0. That means this is positive answer. Although this answer is in 2's complement representation, but since you can see initial bit is 0, that means it would be equals to sign magnitude representation only. It would be equals to sign magnitude representation only. So although you can take 2's complement here, if you take 2's complement, you will get the same thing. What will be the 2's complement of this? The same thing. So same thing you will get here. So that would be equals to sign magnitude representation. So what will be the sign magnitude representation here? Plus 1, 2, 4 plus 5. So again this is incorrect answer. Why did you get incorrect answer here? because they are lying out of the range. They are lying out of the range of this. That's why you are getting the incorrect answers. How can I get correct answer? If I represented these bits in 5 bits, using 5 bits, how many numbers you will get? Minus 2 to the power 5 minus 1. That would be minus 2 to the power 4, minus 16 to plus 15. These many numbers you will get. And plus 11 and minus 11 will lie in this range. So if I represent the number in 5 bits and I perform the addition, or if I perform the calculation, you will get the correct answer. Do the same calculation using 5 bits. So what will be the complement, 2's complement using 5 bits? That would be this. And what about this? That would be this. Perform the addition. 1, 1, 0, 1 and this 0 as it is. Here carry is not generated. In this case carry was not generated, answer was negative. Although this concept was working here, answer was wrong, but this concept was working now, that carry is not generated, the answer is negative. Here this calculation could have been done using these bits only, but you are using more bits. So these are not the minimum number of bits you are using. This calculation could have been done in these many bits, but you are using 5 bits here. So this is not the minimum number of bits. So if I say that sir carry is not generated, that means answer should be negative. That concept is wrong here. Why it is wrong? Because you are not performing the calculation using minimum number of bits. You are using more bits. So that's why that carry generated, carry not generated, that concept will not work here. So this answer is in 2's complement form only, but here you can see, what you can see, that my initial bit, sign bit is positive. That means this is equals to sign magnitude representation directly. So directly I can tell the answer. So 0 will tell plus 1 0 1 1 0 1. So 1 2 4 8, it is 11 only. So see, you are getting the correct answer. Correct. You performed the same addition using 2's complement representation only, but you used one extra bit. And why is that so? Because range of numbers in 2's complement representation using 5 bits is minus 2 to the power 5 minus 1 to plus 2 to the power 5 minus 1 minus 1. That would be minus 16 to plus 15, and plus 11 and minus 11 lies in this range. Okay, so that's why answer is correct. This answer will also be correct. You need to represent it in using 4 bits. So 1 1 0 1 0, 1 1 0 1 0, right? This is correct. I am writing the 2's complement of minus 6. 2's complement of minus 6 using 4 bits is 1 0 1 0. So how it will be using 5 bits? This one will be repeated. 2's complement of minus 5 using 4 bits is 1 0 1 1. So how it will be in 5 bits? That would be 1 0 1 1 and 2 times 1 repeated. 2 times 1 repeated. So just the sign bit gets repeated. In the previous lecture we have seen it. So the previous lecture was the prerequisite of that, right? So 1 plus 0 is 1. This is 0 1. 1 plus 0 is 0. 1, sorry, 1 plus 1 is 0 and 1 goes here 1, and again you are getting 1. So since now you will say that sir, if carry is generated, that means answer should be positive. But no, answer will not be positive. Why so? Because this carry thing will not work here. That will work only with the minimum number of bits. So now this answer you are getting, this is the final answer, but this answer is in 2's complement form. This answer is in 2's complement representation. You need to get it in sign magnitude representation. So what you will do, you will take again 2's complement, because this answer is what? This answer is negative. If the answer is negative, sign magnitude representation and 2's complement representation will not be same. If the question is being asked that we need the final answer in 2's complement representation, then this would be the answer. But if the question is asked we need the final answer in sign magnitude representation, then you need to take 2's complement. So one here, one starting from here, and all are complemented. So what is the final answer? Here you can see it is first bit for sign, so minus 1 2 4 8 11 only. What you get? Correct answer. So if they are lying in the range, that means the answer is correct, but here the answer is incorrect. Why is that so? Because of overflow. What do you mean by overflow? That means your answer is going out of the range. So here overflow has occurred. Overflow has occurred since your answer is getting out of the range, that means we can call that overflow has occurred. Okay, so that's the thing. This is the concept of overflow. We will see a lot more things in this particular concept. We will see more things. So what is the conclusion? If addition of two positive numbers results in negative number, or addition of two negative numbers results in positive number, that means the overflow has occurred. Positive number result is negative, negative number result is positive, so overflow has occurred. Now let's see a question. In the following operation, if the following operations are performed using 2's complement representation using minimum number of bits possible, then which of them will result in overflow? 3 plus 2 is 5. Look, 3 can be represented in 3 bits. Using 3 bits, what will be the range of 2's complement? Using 3 bits, what will be the range of 2's complement? Range of 2's complement representation, that would be 2 to the power 3 minus 1, that means minus 4. So minus 4 2 plus 3, that would be minus 4 2 plus 3. Using 4 bits, what that would be? It would be minus 2 to the power 4 minus 1, so minus 2 to the power 3, so minus 8 2 plus 7, minus 8 2 plus 7. So if you perform this addition, you will get answer as 5. 5 will come in this range? No. You can write it using 3 bits. You can write this as using 3 bits. But for this you would need 4 bits, because 5 will come in this range. So for this you would need 4 bits. So overflow will occur here. 3 minus 2. If there are opposite sign, overflow will never occur. Because what will be the answer? 1. For 3 you need 3 bits. For 2 you need 3 bits. For 3 you need 3 bits. For 2 also you need 3 bits. For 1 again you need. It can be represented in 2 bits as well. But in 3 bits it will come. In this range it will certainly come. Now you will not say that, sir, okay, 2 cannot be represented using 3 bits. So yeah, forget it. So for this as well you need 3 bits. For this as well you need 3 bits. This can be represented in 2 bits as well, or in 3 bits as well it will come. So for this as well you need 3 bits. So overflow will never occur here. And you can see whenever there are opposite sign, here there is plus sign, here there is minus sign, overflow will never occur. In this as well overflow will never occur, because answer is minus 1, that is coming in this range. So here also overflow will never occur. Here overflow will occur, because there are opposite signs, so answer will be minus 5. Answer will be minus 5, that is flowing out of the range. So overflow will occur. 4 plus 2 is 6. So 2 will come in this range. Sorry, yeah. But 4 will not come in this range, so we need to use 4 bits. Basically the thing is, you can represent 4 using 4 bits. Using 3 bits you cannot represent 4. And for this you can represent it using 3 bits only, but we have to use equal bits. So for this as well 4 bits will be required. And where the answer will lie? Okay, answer will lie in this range only. So answer will also lie in this range. Are you getting this point? So plus 4 in this range, using a minimum number of bits. That means using 3 bits you cannot represent plus 4. So you will have to use 4 bits. So you are using 4 bits here. In 2 as well you will use 4 bits. So answer is 6. So that is lying in the 4 bits as well. So there is also no overflow. Although the signs are same here. The signs are same. Still there is no overflow. Here the signs are same. Again minus 5, minus and minus. We need to check, will there be any overflow? What will be the answer? Minus 6. So minus 4 can be represented using 3 bits. Minus 4 can be represented using 3 bits. Minus 2 can be represented using 3 bits. But can minus 6 be represented using 3 bits? No. Minus 6 cannot be represented. You need to use 4 bits for that. So overflow will occur here. Opposite signs are there, never overflow will occur. Here plus sign is there, here minus sign is there. Here plus sign is there, here minus sign is there. Overflow will never occur. You do not even need to check for the opposite sign. For opposite sign, overflow will never occur. So you don't need to check. But for the same sign, here plus sign is there, here minus sign is there, here plus sign is there, here minus sign is there. So you need to check that 4 can be represented using 4 bits only, and 2 can be represented using 3 bits, but we need to take the maximum of this. So you need to take 4 bits only. Now what is the final addition? That is 4 bits. So 6 can be represented. Sorry, what is the final addition? That is 6. So 6 can be represented using these number of bits. So yeah, answer would be correct. Overflow will not occur here. So in 1, 2, 3, only in 3 conditions overflow will occur. Are you getting this point? So this is how you can check it. You do not need to solve it using binary, or you again and again you do not need to check the complement. If you have the concept clear, in that manner also you can check it. Now we checked the condition of overflow using, like, let's just say only this thing was given and they asked you whether the concept of overflow will occur or not, and you cannot convert the number into decimal. Here we converted the number into decimal, then we can say the overflow will occur, sir. But what if you do not, cannot convert the number into decimal? By looking at the binary only, you need to tell whether the overflow will occur or not. So how will you do that? How will you do that? So let's check this thing. Okay. So let's take the example of 3 and 2 again. So we will check how we can do it. Okay. That I want to let you know. So here plus 3 minus 2. So what will be plus 3? That would be 0, 1, 1. And what would be minus 2? Minus 2 can be represented as, minus 2 can be represented as this. So what will be like minus 2? For minus 2, what will be 2's complement of that? That would be this only. For minus 2 means 2 to the power 1. So only 1 0 would be there. So this will be the 2's complement of minus 2. But you have to increase sign bit. Why you need to increase sign bit? Because you need to denote both of the numbers in 3 bits. Or you can say like this is the sign bit and 1 0 is the magnitude. Basically, what I am doing, minus 2 first you represent in sign magnitude representation. What that would be? 1 here, 1 0. Right? Now I need to take 2's complement. How will I take 2's complement? Sign bit as it is, start from the back, 0 and you get 1. After that there is no number. So this is the 2's complement representation. Or you can write it 1 0 only. 1 0 or 1 1 0, both are same. So 1 1 0 I am writing. Right? This is the 2's complement representation. Now you need to add them up. So 1 0 0 and 1. Since we are doing it in what do we say, 1 plus 1 is 0. So here there is 1 carry, that also I am writing, and 0 plus 1 and 1 plus 1 is 0 and 1 carry. So you need to ignore the 1. If I ignore the 1, what is the answer I am getting? Plus 1 only. So the answer is correct. Here overflow will not occur. So the final answer we don't need to write. Only we need to check overflow will occur or not. So 2 minus 3 overflow will not occur here. 2 will be 0 0 1. What will be 3? 3 will be 0. 3 will be 1 0 1. That would be 3 in 2's complement representation. If you perform it, I know overflow will not occur. But 1 plus 1 is 0. 1 goes here, that I have written, and 0 plus 1 is 0. Answer will be minus 1 actually. Okay. So here you can check there is no carry. Here also there is no carry. Okay. Let's see this one. 3. 3 will be 0 1 1. What will be 2? 0 1 0. Perform the addition. Here I know overflow will occur because 5 will go out of the range. 1 0 1 goes here. 1 plus 0 is 1. 1 plus 0 is 1. Here there is no carry. Minus 3 and minus 2. So how will you represent minus 3? 1 0 1. How will you represent minus 2? That would be 1 1 0. Right? Perform the addition. What you will get? 1 1 1 plus 1 is 0, and you get 1 carry here. Here you did not get any carry. Now if I am calling this as C in, okay, and this as C out. If I do this calculation, C in XOR C out, what I am getting here? 1 XOR 1, that is equal to 0. C in XOR C out. Here there was no carry. Here there is no carry. 0 XOR 0 is 0. In both of the conditions, overflow did not occur. Here, if I do this calculation, C in XOR C out. 1 XOR 0. Here there was 0. Here there was 0. Here also this was 0. This is also 0. So C in XOR C out. 1 XOR 0. 1. C in XOR C out. What is that? 0 XOR 1. this scene is known as carry into the MSB bit. This bit is MSB, no? This one MSB. So carry into the MSB bit. And this C out is known as carry out of the MSB bit. Carry out of the MSB bit. So what is the conclusion you are getting from here? If C in XOR C out is equals to 0, that means there is no overflow. Using the bits only, I am not converting the number to decimal. If only this was given, I could have seen here and here. Okay, C in XOR C out is becoming 1. That means certainly if you convert this number into decimal, the overflow will occur. Directly from here only I can tell that C in XOR C out is 1, that means overflow occurs. So this is the important point that we got to know, that you can see from here. There is one more thing. What is that? So this is the first condition, that if this kind of number is there, which I have represented in 2's complement, answer will also be in 2's complement. This is C in, C out I can write here as well. C out I can write here as well. So C in XOR C out would be 1. So that is the condition of overflow. What could be the other condition? There is other way to check it as well. What is that? We will take the overflow example only. 0 and 0 both are positive number. You are getting answer in 1. You can see if this number is represented in 2's complement form. If there is a particular number represented in 2's complement form, let's just say I am saying that this number is represented in 2's complement form. Now I am asking you whether this number is positive or negative. You can tell, sir, certainly this number is positive, and this number is represented in 2's complement form. You do not know what is that number. The only question is, tell me whether this number is positive or negative. You will say that, sir, certainly this number is negative, because first bit will show the sign. You can tell it, no? If this number is given and I am saying that this number is represented in 2's complement form, tell me whether it is positive or negative. You will say, sir, it is positive. If this number is represented in 2's complement form and I am asking you whether it is positive or negative, sir, you will say that, sir, it is certainly negative. So this is a positive number, this is a positive number. In the answer you get 2's complement form only. Certainly you get 2's complement form. And in the answer you are getting negative number. So 0 and 0 is there, but in the answer you are getting 1. Here this is a negative number, this is a negative number, but in the answer you are getting a positive number, 0 1 1. That means overflow has occurred. So what I can write here, that if an is 0 and bn is 0 and sn is 1, an is 0, so an 0 means I am writing SOP form. So if it is 0, I will show it an bar. If it is 0, I will show it bn bar. And then if both are 0 and your answer is becoming 1, or if an is 1 and bn is 1, that means both are negative, still your answer is becoming 0. That means overflow has occurred. So one of the condition you need to check, if one of them is working, like if one of the condition is there that C in XOR C out is 1, or 0 0 you get 1 here, or 1 1 you get 0 here, that means overflow has occurred. Overflow has occurred. That's the concept of overflow. So in bits only, if the numbers are represented in bits in 2's complement representation, then how you can directly tell C in XOR C out is 1, or this is this MSB bit 0 0 1 1 1 0. All this is happening with MSB bits. These all are MSB bits. So you just need to focus on MSB bit. You need to see the carry in and carry out. If XOR of both of them is 1, then overflow has occurred, or if this condition is there, that means overflow has occurred. So if the example is given in decimal, then you do not need to convert it to binary and check if the overflow has occurred or not. And if the answer is given in binary only, then you do not need to convert it to decimal and check the answer. Are you getting this point? Although we should not say binary, we should say 2's complement. So basically, if numbers are given in decimal, you do not need to convert it to 2's complement. If numbers are given in 2's complement, you do not need to convert it to decimal. By looking at the final answer, you can tell whether the overflow has occurred or not. I hope the concept is clear, and this concept is confusing to a lot of people, but I tried to bring it down in small pieces, and this is the final conclusion. This is the final conclusion. So everything is clear about this particular chapter. Now let's see what else we have. So these are the questions only, so we can solve these two problems would be there. Now we will see why did we studied this particular 2's complement representation calculation or 1's complement representation calculation. Why did we study it? Okay, so the question is given, two numbers are represented in binary, perform p minus q without converting it to decimal. You need to perform p minus q. Can you tell me what is this number? Will you say that, sir, it is minus something? No, you will not say that it is minus something. Why you will not say that? Because the number are presented in binary. This is not sign magnitude form. This is binary form. You need to perform the addition. What you need to perform the operation? What is that? P minus q. You need to subtract 1010 minus 11001. You need to do this operation. Can you do it using binary subtraction? We have studied binary subtraction in last two videos, I guess. In last to last, we have studied binary subtraction. Can you do it? I can assume 0 here. So this would be 1. This would be 0, 0. This would be 1 minus 1, 0. Now, how will you subtract 0 from 1? How will you subtract? There is nothing to borrow. You cannot subtract, right? So, using binary operation, you cannot do this subtraction. So, what other methods you are having? You will say that, sir, I have one more method. What is that? Sir, I can use 1's complement representation. So, if I am doing using binary subtraction, using binary subtraction, we are not getting the final answer. But use 1's complement representation. If I use 1's complement representation, then what I need to perform? P minus q, or I can write plus p plus minus q. So what will be your plus p in 1's complement representation? Tell me. Take your time and tell the correct answer. What will be your plus p in 1's complement representation? Look, this particular, without converting it to decimal, this particular number is given. Okay, that will show the magnitude. This number shows the magnitude, right? This number will also show the magnitude. This has nothing to do with the sign. So you know that this is your magnitude. You know the magnitude bits. These are the magnitude bits. Since there is plus sign, there you go. You put 0. These are the magnitude bits which are shown by the binary. Since there is plus sign, I can put one more 0. Now it is plus p. It is in sign magnitude form, which is equals to 2's complement form as well. So sign magnitude representation, which is equals to 2's complement representation. Are you getting this point? But I will add another 0 here because I know this will require more bits. So what will be your plus q? Sorry, what will be your minus q in sign magnitude representation? So I know these are the sign. What do I need? Minus q. That means 1 will be here and this will represent the sign. So 1, 1, 0, 0, 1. So this is your sign magnitude representation. You need to get 2's complement. How will you get? 1, 1 here, 1, 1, 0, 0. So this is your 2's complement representation. So you have denoted plus p and minus q in 2's complement representation. So now you will perform the, okay, I am doing it using 2's complement. So let's write 2's complement here. Using 2's complement representation. Then I can do it using 1's complement. So this I have converted into 2's complement. Now you can perform the addition. So what you will do? 0, 0, 1, 0, 1, 0 and 1, 0, 0, 1, 1, 1. So 1, 0, 0, 0, 1 and 1. Carry is not generated. Carry is not generated. And what is this answer? This answer is in 2's complement representation. This answer is in 2's complement representation, right? We are performing that 2's complement representation addition. So answer is in 2's complement representation. Now if you need SMR, then what you will do? Sign it as it is, this here as it is, and again take that 2's complement, right? 1 as it is. So this is 1, this is 1, this is 1, and 1 0. So what is the answer we are getting? Minus 15. So without converting it to decimal, I have got the answer, that is minus 15. And if they are asking like do this operation and write down the final answer in 2's complement form, then this would be the answer. Do this calculation and write down the final answer in sign magnitude form, then this would be the answer. Using binary subtraction, you were not able to do it. Did you understand the concept what we are doing here? Binary number were given, you needed to perform the addition, you needed to perform the subtraction. Let's convert it to binary. What that would be? 1 2 4 8. So that would be 10. This number is 10. So p is actually plus 10. P is 10 only. Why should I write plus 10? P is 10. And what is q? 1 2 4 8 16. That is 25. Q is 25. So you need to perform 10 minus 25. The numbers are given in P and Q, but you cannot convert it to binary. That is the task. Sorry, you cannot convert it to decimal, because how will your computer perform it? How will your computer perform this calculation? He cannot convert it to decimal because he cannot understand 2, he cannot understand 5, he can understand only 0 and 1. So he is not going to convert it to your computer, your digital circuit. He is not going to convert this number into your decimal number and then perform the addition, and then it will convert it to 2's complement or sign magnitude. This is what your computer will never do, because he cannot understand 25 and 10. So how will your computer perform this addition? This is what the question is asking. So how will your computer will perform this addition? So this is how your computer will perform the addition. What he will see, I cannot subtract p from q. I cannot subtract p from q. Then what I can do? I can use 2's complement representation for this particular calculation. So what I will do? I will do plus p plus minus q. So plus p in sign magnitude form will be the same as this only, and this will represent the magnitude. This is representing magnitude 1 0 1 0. I will put a sign bits are there. So this will be the same 2's complement representation. What about minus q? So this is representing the magnitude, and since minus sign is there, so one more bit I will put. So this is my sign magnitude representation. If I need to take 2's complement, so this will be my 2's complement. So this is the 2's complement representation, and this is also 2's complement representation. I will simply add it up now. So this is the final answer I am getting, which is in 2's complement representation. So if I convert it to sign magnitude representation, then again I need to take 2's complement, and this is the answer I am getting. So final answer is minus 15. So this is what your computer will do. So if you are an engineer and you need to design a circuit which will do the addition and subtraction of any binary number, then you will use 2's complement. You will not convert it to first decimal and then you will convert it to 2's complement. You will not do this thing. As a designer, if you need to perform the subtraction, what you will do? You will first get the 2's complements and then you will perform the addition. Are you getting this point? So I will design only a adder, and from that adder only I can do the subtraction as well by the help of 2's complement. Is it understandable to you or not? Right? And how will I do 1's complement? The same thing I can do with the 1's complement as well. So plus p in 1's complement representation, what that would be? That is 00 would be there, or 10 only you can put. Since 1's complement representation, sign magnitude representation and 2's complement representation will be same for plus p. What about minus q in sign magnitude representation? That would be minus q. So first bit will be sign 1 and then 110 0 1 1 110 1 110 0 1 1 1 0 0 1. So what will be 1's complement representation of that? So sign bit as it is, and then magnitude of complement of all those. Now you need to perform the addition only. Now I hope it is clear why do we use 1's complement. Like you say, sir, I am smart. If these kind of questions are asked in the examination, first I will convert it to decimal, then I will perform the simple addition subtraction, and then I will get my final answer. You can do it, but your computer cannot do it, and you need to design the computer. So that's the thing. 1 1 and 1, right? So this is the answer, which is in 1's complement form only. This answer is in 1's complement form. So if you need to get the answer in sign magnitude form, then what do you need to do? To get the answer in sign magnitude form, this is what you need to do. So this answer will be in sign magnitude representation. So yeah, this is the correct answer. Okay. Now the next one is a gate question. So the subtraction of a binary number y from another binary number x is done by adding x minus y you are doing. X minus y you are doing. What they are doing? X plus 2's complement of, by adding that 2's complement of y to x. 2's complement of y to x. Wait a second. Yeah, so what I was saying, x minus 5 they are doing, so x plus 2's complement of y, this is what they are doing, 2's complement of y. So this is how they are performing the addition, and the results in binary number without overflow, this implies that the result is what? Okay. So what will be, if there is no overflow, that means normal condition is there. So if normal condition is there, then what could be the case? The answer could be negative or positive. So answer could be negative or positive. If answer is negative, answer could be negative or positive. Both the answer will be in 2's complement form. This will also be in 2's complement representation only, and this will also be in 2's complement representation only, right? But if this answer is in 2's complement representation, then you can say that it is in, you can say it is in SMR, sign magnitude representation, or you can say that it is in 2's complement form, or you can say that it is in 1's complement representation as well, or you can say it is in normal form as well. All the same will be, all the form will be same for positive answer. For negative answer, only this is correct. So answer could be negative and in 2's complement form. Answer could be negative in normal form, wrong. But answer could be positive and normal form, yes. Answer could be positive and in normal form. Answer could be positive and 2's complement form, yes. But wait a minute. This was the gate question, and probably all these answer could be correct. But this came in 1987. This came in 1987. In 1987 means like there was no MSQ. So they did not give these answers. Okay, they did not give these answer. They gave only this answer. So answer is, if answer is coming negative, then certainly it will be in 2's complement form. This option would be correct. But they did not give these answers. These should be the answer as well. That if answer is that your result can come positive and it would be in normal form, and your result can come positive and it would be in 2's complement form. Now someone will have one doubt here, that sir, you are doing x plus 2's complement of y. This is what it is written. It's done by adding 2's complement of y to x. But here it should be written that sir, 2's complement of minus y, not 2's complement of x. It should be written in that manner, no? That it is done by adding 2's complement of minus y to x. Like tell me, let's just say y in binary is this, y in binary. This is the binary number, okay? Y in binary is this. What will be plus y in SMR? That would be this, right? And what will be minus y in SMR? That would be this. So like sometimes in the questions they can say that I am taking 2's complement of y. That means they mean that they are taking 2's complement of minus y. Are you getting this point? Like sometimes in gate examination it happens that if they are taking 2's complement, like tell me one thing, this is your SMR, right? And this is also your SMR, and this was binary. Aren't both these things same? I can write in this manner as well, no? And this would be equal to 2's complement as well. So if a number is positive, then why would you take 2's complement of that? If number is positive, then the same thing you are getting, no? So sometimes in the examination, if it is written that we are taking 2's complement of y, that means they are considering it that y is already negative. That's why we are taking 2's complement. Here 2's complement will be different. That would be 0 0 1 0 1. So both things are different here. But in that case, both things were no different. Here minus y is there, so both things are different. 2's complement and 2's complement. Both 2's complements are different here. But if we are talking about these two, plus y and minus y, they are the same. So sometimes it may happen that in the examination it would be written that you are taking 2's complement of y. That means they are considering 2's complement of minus y. Okay. It would be rarely that they will ask that 2's complement of a positive number. If they are talking about 2's complement, that means they are talking about negative number only. So it might happen in your examination that you need to think, if they are asking for 2's complement, you need to assume that a negative number, that means first sign bit will be 1. So what is the 2's complement? What is the 2's complement of y? As per them, the 2's complement of y is 0 1 0 0, and this is the sign bit. So they are forgetting the sign bit, and this is their 2's complement. And let's just say x was this 1 0 1 0. So what they are doing, they are taking the 2's complement of y and they are adding that up. So answer is negative and it is in 2's complement form. So this answer would be in 2's complement form. Now let's just say if this number was this 0 0 1 0. So here also there is no carry. Okay, there is no carry. Let's just say if this number is 1 only, and if this number is also 1. So in 2's complement, if this number is 1, so here you can generate a carry. So 1 plus 1 is 0, and this would be the carry. So if carry is generated, then the answer would be positive, and this answer would be in normal form or in 2's complement form. So both C and D could be correct. But wait a second, this carry will go here actually. In our actual calculation, this will be 0 and this carry will go here, and here carry can be generated. So carry is anyway generated only. So certainly C or D both could be correct. Okay, so there is no chance then we can make those incorrect. Certainly both will be, C and D will also be correct, but they did not give the answer. They did not give these options in the answer. They only gave B. So if it was coming as MCQ, then I would certainly click on this only, because that's pretty sure that if answer is negative, it will be in 2's complement form only. But here both of the options are being correct, so I will not click on this. But if it is in coming in MSQ, then I will certainly click on C and D as well. Okay. So yeah, this is what they were thinking of this question. So this is a bit controversial question as per me. A lot of teacher would give only these two answers, the positive and in normal form. But if it is in positive, then certainly it is in 2's complement form as well. No, so this should be the answer as well. So all three options are correct. The first one is wrong. Negative and in normal form, that cannot happen. So yeah, that's it from my side about this particular chapter. So this 2's complement chapter we have studied. We have studied the complement arithmetic as well, which is somewhat complex, I know, and people are confused a lot of times in this particular chapter. But I hope we have covered everything in smaller steps. If you are not able to understand this, watch the video again. You will certainly be able to understand. Slowly move forward, and it will be all clear to you. Okay then. Thank you very much. Now we are going to see an assignment, and then we will start our combinational circuits. So we will see the assignment now.